Okay, so in this case, we've got a sample of sodium disulfate. It's hydrated and its mass is 6.43 grams, and we effectively need to figure out what the value of X is in this formula here, right? So how are we going to go about doing that? Well, in this particular case, we've also been given the mass of the anhydrous sample, right, here. What we can try and do is figure out a way to compare the moles of the H2O present with the moles of the Na₂S₂O₃, the sodium disulfate present, and that would give us an idea of maybe what the ratio is, and subsequently what the value of X is likely to be. Okay, so we've got the mass relating to sodium disulfate, but we don't have the number of moles just yet. But because we have the formula, we can actually work out what the number of moles is. We're going to use the formula. The number of moles N is equal to the mass divided by the molar mass Mr, right? So in this case, it's the number of moles for Na₂S₂O₃, right, is equal to the mass M. So that's going to be, in this case, it's going to be 5.71. Yeah, and divide that by the molar mass. So we need to use the periodic table. So Na₂S₂O₃, you can see the values there. But so we've got 22.23, 32.1, and for oxygen, of course, we've got 16, right? So so if I say the molar mass of Na₂, that's an N, just to be Na₂S₂O₃, is going to be equal to 23 times 2, right, plus 32.1 times 2, right, plus 16 times 3. Okay, and that, if you work that out, what you should find is that you get 158.2. okay, and that's going to be in grams per mole. Okay, all right, now the other thing I'm going to do here is we do need to work out the number of moles of the H2O. But before we get that, let's finish this out. So 158.2, right? So if you do that, you're going to work out what the number of moles is for the sodium disulfate. And this when you work this out, this should give you 0.036094, right? And that's going to be in moles. Okay, and at this stage, I'm going to now look into the number of moles for the H2O, right? Now, we don't have a mass for the H2O just given, but with a bit of arithmetic, we can work out what that is. So we have the hydrated mass, which is the 66.43. We have the anhydrous mass, which is 5.71. Now, if we do the hydrated mass and we subtract from it the anhydrous mass, what we're effectively subtracting is the mass that's contributed by the sodium disulfate, right? So what we can deduce is whatever is remaining is contributed by the H2O. So if you do 6.43 minus 5.71, so that's going to give us 0.72, okay, and that's going to be in grams. So this is effectively the mass of the H2O, right? And now that we've got that, we can work out the number of moles for the H2O, right, using the same equation here. So we can say that the number of moles for H2O is going to be equal to 0.72 divided by the molar mass of H2O. Now, you may know what that is, but you can just work that out from the periodic table. So yeah, I just noticed this oxygen is here twice. It doesn't need to be there but twice. But anyway, effectively, if you get H2O is going to be 1 times 2, right? So 1 times 2. So this is the MR of H2O, right? Plus the molar mass for the oxygen, right? So that's going to be plus 16, right? So or you could say like the relative atomic mass of oxygen. But anyway, plus 16, and that's of course going to give us 18, right? And that's going to be in grams per mole. All right. So using this 18 value, we can insert this into the equation we've got here. So divided by 18, right? And that's going to give us the number of moles for the H2O, which in this case is going to be 0.04 moles. Okay. So we've got both now. If we refer back to the equation we have here, what you can see is that sodium thiosulfate is on the left-hand side, right? And the H2O is on the right-hand side, right? So for the next steps, when I'm going to be comparing the molar ratios, what I'm going to do is put the ratio of the moles corresponding to the sodium thiosulfate on the left-hand side. So I'm going to say the number of moles of Na₂S₂O₃ as a ratio compared to the number of moles of H2O, right? So we've got the, as you can see, it kind of corresponds with what we effectively will have in the final setup. So makes things a bit more easier to follow. So on this side, it's going to be what? It's going to be the value we calculated here, right? So 0.036094, and that's going to be in ratio with 0.04. Okay. Now, in our original formula, which we're trying to basically use as the basis of well, for every, what the formula effectively articulates is that for every 1 mole of Na₂S₂O₃, we're going to have X moles of H2O, right? So, but in order to really make sense of that, we need to get the number of moles corresponding to the Na₂S₂O₃ to be 1. And we can do this here by dividing the moles corresponding to the Na₂S₂O₃. We can divide it by itself. So 0.036094. And now what if we do on the left hand side? Because it's a ratio, we also need to do on the right hand side. I mean, the ratio symbol is not an equal symbol, but it is an equation where, you know, if you do something here, we have to do it on the other side as well. So okay, so we also need to divide this by 0.036094. Okay. Now on this side, we're dividing a number by itself, so it's going to give us 1, right? But on this side, you know, it'd be useful to kind of use a calculator to work that out. But what you should find is that you get 1.1082 on the right hand side. All right. Now, what you notice is this is very close to 1, right? And generally speaking, when we're dealing with waters of crystallization, we're dealing with integer values. So what I'm going to do is effectively round this to the nearest integer value, which is 1 in this case. So we can say that the 1 is actually in a ratio of what is approximately 1, right? And therefore, x is equal to 1. Now, if x is equal to 1, then therefore we can say that, well, Na₂S₂O₃ is going to be, let's just write it here, down here actually, Na₂S₂O₃ dot, and then it's going to be 1 H2O, right? Now, in reality, you do not need to put a 1 there because it is just 1. So, you know, like just like in this case, you don't need to put a 1 there. So it would effectively be Na₂S₂O₃ dots and then H2O, right? But for the purposes of this question, it does say, you know, enter the value, you know, enter answer what the value of x is going to be. So just for the purposes of this question, I will put that 1 is, you know, it's going to be 1, right? Okay, yeah, so that's how you'd work that out.